Hello, everyone. Welcome to this session on data bias and data nutrition label. As you have already known, all the AI models are trained on data set. So just like our human body rely on food for growth and for energy, the AI model also need to rely on data set in order to learn and to make their decisions. So the quality of the data set is super important for the quality of the model. And specifically, the completeness and the diversity of that data set will play a critical role in determining how healthy the model will become. So you can imagine if you train the model fully based on some bias and low quality data set, it's just like a person living on junk food, right? That person won't be very healthy. And similarly, that model won't be very healthy. And what's worse, the model might be even bringing out more harms than benefit to its users. So this is a phenomenon that is widely known as garbage in and garbage out. It means that if you feed the model always with garbage, then what the model can return to you is only garbage, okay? So we need to really pay attention, real attention to the quality of the training data set. And also when we are evaluating models output, models performance, we also need to take into account the quality of its training set. Okay, so now, let's get into the details. First of all, I want to introduce a story about gender bias. According to a study done by Zhao and his colleagues, they find that over 45% and 37% of the objects inside a popular data set exhibit some gender bias. So it means that for example, okay, cooking is 33% more likely to involve females than males in this data set. And similarly, shopping, guess what? Yes, shopping is more closely associated with female, while shooting is more likely to feature males in this data set. Okay, there might be someone and Penny say that, okay, this is just reality, right? What's wrong with reality? Female more likely to do shopping than males, and the data set is just reflecting the reality. However, I want to emphasize that this study has found that if you train the model based on some gender biased data set, then the resulting model will further amplifies this disparity to a higher degree, specifically to 68% at the test time. In other words, the model training will amplify and also will enhance that existing disparity between genders. It is not just merely reflecting the same degree of disparity in the data set. Instead, it will raise it to a higher degree. That's the reason why we need to pay more attention to training data, and also we need to be more cautious about the gender distribution of the training set used for a certain model. Okay, and here is another case, and it's more serious because it is about the gender bias in AI recruiting tools. Nowadays, many leading companies are using AI tools to review and screen candidate profile and only retain those candidates that the system believes are suitable for the position. So notably, a large number of candidates will be screened out and be excluded without being provided further opportunity to be interviewed in the next stage. So this process has given AI system a very large, a very great power, probably even greater than most of the human resource officers. Okay. However, some people have found that the gender bias is prevailing under this kind of AI tools, AI systems. Specifically, they will underrate female candidates for some technical positions such as computer programmer, but also for the management-related position such as a senior manager or executive officers. And this kind of bias will amplify the existing gender inequality in the job market, right? Finding a job is already hard Finding a job is already challenging, but AI might probably even add to the existing challenge that you are facing if you are unfortunately a female candidate who are looking for a technical position. So we need to, once again, be more cautious about this kind of gender bias underlying the seemingly neutral, seemingly scientific tools that the company is using. In addition to gender bias, racial bias is also widely observed. So the picture below have shown that Google Vision mistakenly classified a monocular held by a black hand as a gun. However, if the same monocular is held in a white hand, then the system will correctly identify it as a monocular. So as you can imagine, this kind of mislabeling will be very dangerous if the system is used by a police. Then the police might very likely to arrive at some misjudgment and probably identifying an ordinary black people holding a monocular as a criminal holding a gun. And then that black person might be arrested because of the error made by AI system. And this will be very dangerous and will be very harmful for those innocent person. Besides, the AI-powered risk assessment system were also found to mislabel Black American as high risk and nearly twice the rate it labeled White American. And this kind of risk assessment system now is laid the foundation for the judiciary decision in many developed countries. So if the system is biased, then the judiciary decisions are also very likely to be biased by the system's output. So this will further amplify the existing racial inequality in the society. And the things can be even worse when the gender bias meets racial bias. Most of the computer vision datasets are overwhelmingly composed of lighter-skinned subjects, such as white people, with only 20% of samples are collected from people with darker skin, such as yellow people or black people. So it means that people with darker skin are significantly underrepresented inside such a dataset being used for model training. So consequently, the resulting computer vision model, specifically the facial recognition system, will have a better performance on lighter skin compared to darker skin. Okay, and similarly, they have found that all the classifier will perform better on male faces than female face. Okay, so when these two characteristics intersect, it becomes a very challenging situation for Black women to use such a system for their own benefit. For example, we have heard many stories that the computer vision systems such as Google Vision will mistakenly recognize a Black woman as gorilla, okay, which is very biased and even racist. And sometimes, or say oftentimes, Black women will have a difficult time in turning on their cell phone using Face ID, okay? So the gender classification are most likely to misclassify darker skinned females with an error rate up to 34.7% compared to the low error rate of 0.8 for lighter skinned males, okay? So we should not be misled by the seemingly impressive performance result in aggregate, because sometimes the company may try to promote their models by presenting performance results in total, such as an extremely high accuracy rate at 90% or even higher in total, covering all population. However, if you break down the performance results by racial or gender or other demographic groups, sometimes the model performance might deteriorate substantially for some distinct subgroups. So if a model cannot have good performance over Black people or over females, we should not call it a great model, right? So that's something I want you to keep in mind. Every now and then we need to try to have a more comprehensive and also a more fine-grained evaluation of model output, and try not to be misled by the performance result reported in aggregate. In addition to gender and racial bias, we have also seen quite a number of examples pointing at the geographical bias. And this is not hard to understand, right? Most of the popular and widely used AI models are developed in Western countries. So the lion's shares of their training data are collected also from Western background, and that can only reflect Western's lifestyle, Western's understanding of the concept, and also Western's cultural backgrounds. However, across the country, the same concepts can carry very different meanings and evoke distinct interpretation among different populations. For example, the same concept of soap might refer to the soap bar in developing country, but refer to the bottle soap, bottle detergent in developed country. And the concept of spice will trigger very different imagination in different populations. And this kind of cultural diversity will not be able to fully captured by the model if the training data set do not include those data points outside of Western context. And this group of researchers have found that the accuracy rate of AI models is positively associated with the income level of a country. In other words, AI models are better at serving wealthy country than the poor country. And the geographical bias of the model is directly reflecting the geographical bias underlying the data set and the data set providers, right? So as you can tell from this image, most of the dataset providers are concentrated in developed country in North America and also in Europe, while people in developing country like China, India have less involvement in this dataset development process. So it is critical to dispel the myth that engineering practice like model training, model validation, or model application is purely a technical, neutral matter. It is not, because we just learned that the data set supporting this procedure is always collected and fitted and trimmed for some intended purpose, and also by a selected group of population. And the data set usually will include some hidden hazard that will make the model more biased, probably biased towards a gender, biased towards a race group, or biased towards a geographical location. So the human bias always are built into the data set. So even though the data set includes a lot of numbers, the numbers naturally and inherently will not make the data set more equal. So to mitigate such risks, we should adopt a more deliberated and proactive methodology rather than relying on the convenient sampling and postdoc justification. Now I'm going to introduce one of, I think, my favorite solution for the data bias, which is named data nutrition label. As I have said at the very beginning, the process of model training is very similar to the consumption of food in our daily life. Our human bodies are relying on food for growth and energy, while the AI models are relying on data for learning and also validating the decisions. So we can learn from food industry. Inside the food industry, they have already established a standardized practice for showing the food nutrition label on every food product. So similarly, if the AI model developers try to provide a certain product for the users, they should also consider including AI nutrition facts about their models. For example, what is the privacy level of this model, and whether this model is trained by supervised methods or unsupervised method, and what kind of base model it is drawing on, and what kind of data set it has been used for training the model, and does this data set include the different populations, what is the diversity of the data set, and also whether they have conducted some data deletion in order to improve models' performance. If yes, then how this kind of procedure is conducted. So yeah, anyway, there are a lot of key information that can be included, and we need to advocate for some standardized practice among the key practitioners and the key leading company to establish some common consensus, okay, about what kind of information should be shown to the consumers. And this kind of label will help users boost the AI literacy for their own. Okay, so the AI literacy can not only be developed within the classroom, but also should be cultivated outside the classroom context. It can help the learners to critically assess data quality and try to understand the ethical implication before using the model. So if you know the food is very dangerous, is very harmful, and is very bad for your health, you will not eat it, right? And similarly, if you know the AI model will produce some biased data because it was trained on the biased data set, then you probably will also avoid using it beforehand. However, without such data set nutrition label, we won't be able to make such informed decision about the model that we choose to use. Okay, so including such a data nutrition label can help us and also help other end user to become smarter in model decision. And also it can reduce potential algorithmic harm, encouraging awareness of data set limitation. And also it can promote transparency. Okay, so here are the reference for today's lecture. I hope you can gain some valuable insight out of this lecture. Okay, so see you next week.